promised when we started and looked at geometric mean, and we just introduced very simple meanings of it, definitions of it, that we would go back and I would tell you the real meaning, the definitions, mathematical definitions of geometric mean and where it came from. Geometric mean, what you've known so far has been the mean means the average. Okay? And so what you're looking at is basically what we're looking at is we're looking at the meaning of average. Okay? What does this mean? Meaning of mean, or the meaning of average. Well, you've known it as, if I add a bunch of numbers together, I count those numbers, divide by how many numbers I have, that's the average, or that's the mean. It's a measurement of central tendency or statistics that lets us know, what's the average of a certain set of numbers, grades, so forth and so on. The definition is really of an arithmetic mean. Now in mathematics, the term arithmetic does not stand for arithmetic as such. It stands for, and is the definition of, addition, the sum of. Okay, so an arithmetic mean is made up of a sum of numbers. Okay, and the definition is the quotient of the sum of n numbers and n. So it's a division problem. The numerator is made up of the sum of a certain set of numbers, n numbers, and the denominator is how many numbers that is. So if we take 2 plus 3 plus 4 plus 5 plus 6, divided by, there's 5 numbers, we come up with 20 divided by 5, or the average for that set of numbers is 4. That's the same as saying, wow, if I added 4 5 times, I would get 20. Okay? Or if I multiplied 4 times 5, I would get 20. Okay? In other words, it's an additive measurement of central tendency. Okay? Geometric mean, or the term geometric, has to do with multiplication. Multiplicative average, that's a little different. An arithmetic series or sequence has to do with addition of terms in a polynomial, an endless polynomial with limits. Geometric series or sequence has to do with the multiplication, okay, identity of those same terms, all right, where I'm multiplying to get multiplication. It's a totally different set of, it's a totally different definition of the sequence of terms. So geometric mean is indicated by this. It's the nth root of the product of n numbers. And what we're looking at in geometry is we say, oh, it's the square root of these two numbers. Well, that's the nth root of n numbers. How many numbers do we have? 2. How do we take the nth root of 2 numbers? Oh, that's the square root. But let's look at it this way. Let's take these same numbers and let's take a geometric mean of them. In this definition, that would be the 5th root of 5 numbers. 2 times 3 times 4 times 5 times 6 would be the 5th root of 720, or that equals 3.7279. What does that represent? If I multiplied this number times itself 5 times, I should get 720. 3.7279 times 3.7279 times 3.7279 times 3.7279 times 3.7279 should equal very close to 720. Okay? So it's a multiplicative average of these numbers if I multiply them. It's the number that I would come up with to multiply by itself 5 times to get their product. This is a number I would come up with to add together 5 times to get their sum. Okay? That's the difference in arithmetic and geometric mean. You're going to run into that in your higher level unit honors when you get into college algebra, calculus, differential equations, all kinds of things like that. You get into series, sequences, arithmetic, and geometric series and sequences with limits. Arithmetic mean is what we're used to. It's the average. Okay, now you're responsible for two different definitions. The arithmetic mean, which is the average that you're used to, and now the geometric mean, which is a multiplicative type of average, or the nth root of the product of n numbers.